You are welcome for the lesson on the limiting reagents. We know that when the two species are reacting, there should be one which is consumed earlier than the other. And this is what we are going to determine in this more concept question. This is a past paper question that we are going to go through step by step for us to understand how to tackle questions on determining which one is limiting the reaction process. And so here is the past paper question. Sodium reacts with sulfur to form sodium sulfide. And this is the equation. And 11.5 gram sample of sodium is reacted with 10 grams of sulfur. All of the sodium reacted, but there was an excess of sulfur. So here we have this mass for the reactant and this mass for the reactant. So calculate the mass sulfur left. You calculate the mass which is left at the end of the reaction. And so we are going to now tackle this question. The first part of the question that we are going to tackle is the number of moles of sodium that reacted and the number of moles of atoms that reacted. We only deal with this part here, where we look at a number of moles of sulfur that are actually reacted. And so the first part of the equation is we write a balanced chemical equation. We write the chemical equation, which should be balanced. And the reaction you have is sodium reacting with sulfur to produce sodium sulfur. And you write a 2 there, meaning that this chemical reaction is balanced. And then we are going to look at the mole ratio. The mole ratio on the balanced equation. On the balanced chemical equation. So we have 2 moles of sodium, and we have 1 mole of sulfur, and we have 1 mole of sodium sulfide. So this is the balanced equation. And so we are given the masses. The mass of sodium that reacted is given here, 11.5 grams. And the mass for sulfur that reacted is given here as 10 grams. And so using this, you can calculate the number of moles. So moles for sodium, which is equal to moles for sodium is equal to mass of sodium divided by the molar mass of sodium. And this gives us 11.5 grams divided by 23 grams. 23 grams per mole. So this is the relative molecular mass of sodium. And this gives us 0.5 moles of sodium. We can as well calculate the number of moles, the moles for sulfur, which is equal to mass of sulfur divided by the molar mass of sulfur, which is equal to 10 grams divided by 32 grams per mole. This gives us 0.312 125 moles of sulfur. So that's the first part. Then the second part, you get the ratio of sodium, meaning you get the number of moles of sodium divided by the coefficient. The coefficient on sodium. If you look at the balanced equation here, you notice that the coefficient for sodium is actually 2, this one. And so we are going to say the moles that we calculated for sodium was 0.5 moles of sodium divided by the coefficient, which is 2. And therefore, the R for sodium gives us the ratio of moles. It gives us 0.25. 0.25 moles of sodium. We do the same. We look at the ratio of the sulfur. So I'm going to say the number of moles for sulfur divided by the coefficient on sulfur. These are the reactants. So if you look at the coefficient here, in front there is 1. So you're going to divide the actual moles that we found, which was 0.3125 moles of sulfur divided by 1. Therefore, our R for sulfur is actually the same as 0.3125 moles of sulfur. And so the second step for you to determine which is the limiting reactant, you determine the smallest on R for sodium or R for sulfur. So if you check here, the one which is the smallest, this is 3, as you can see, this is 3.125. So the smallest is actually this one here. So the smallest is 0.25. Therefore, smallest for R for sodium is 0.2. Hence, sodium is the limiting reagent. Okay, this is the limiting reagent. And so now we can compare the mole ratio of sodium compared to sulfur, because the equation is indicating that the first part of the equation is the number of moles of sodium atoms reacted. Okay, so the number of moles of sodium atoms reacted. So the number of moles of sodium that reacted, we have actually found it. So the number of moles that reacted, we have found them. It is the number of moles of this. Yeah. These are the number of moles you determine. So the number of moles that reacted from sodium, which is it. So from the mole ratio, this was 2 moles, while this one was 1 mole. This is from mole ratio. On the balanced equation. And here, the number of moles is 0.5 moles, which gives us X. And therefore, our X is actually the number of moles is actually a 0.5 divided by 2, which gives us 0.25 moles. These are moles of sulfur. So these are the number of moles of sulfur. So we have found that 2 moles of sodium with 1 mole of sulfur, the number of moles of sodium atoms to be actually 0.5 moles. The number of moles of sulfur atoms that reacted, so we are getting actually 0.25 moles of sulfur, of sodium. So this is actually we have just solved this first part and this part. Now, if you are to calculate the mass of sulfur that is left, you have to look at the number of moles, the number of moles for sulfur that actually reacted, which is this one here. So you subtract it. So the number of moles. So if you are to get the mass, so this is what reacted. The number of moles of sulfur. These are the ones. So you can subtract from that one. You see how many moles actually reacted. Okay, so the number of moles that reacted for sulfur, these are the number of 0.25. So, so they calculate the mass of sulfur left. So if these are the ones which reacted, 0.25. So you are going to subtract. Remember, we found that first the number of moles is 0.125. So you're going to have 0.3125. 0.3125 moles of sulfur. That is what was available. Then you have to subtract what reacted, minus 0.25 moles. So these are the moles that reacted. So these reacted. And these were which were actually available. So these were available. So you can subtract to know which ones were unreacted. So the unreacted, the number of moles, you just subtract. So you can use a calculator. Which is we can say actually 0.3125 minus 0.25. So what we get here is actually 0.0625 and reacted. These are moles and reacted. So these moles have not reacted for some, but they want us to calculate actually the mass. So the mass of sulfur left unreacted. And you know that number of moles of sulfur is equal to mass of sulfur divided by relative molecular mass of sulfur. And so for us to get the mass of sulfur, we are going to say the moles of sulfur multiplied by the molar mass of sulfur, which is 0.0625 moles multiplied by 32 grams per gram, which gives us actually, if you have this value, multiplied by 32, it gives us actually 2 grams of sulfur. Did not react. So it means that we have solved our question. Thank you.